You have seen Europa. Nobody has ever seen the ocean it is supposed to be hiding. This is the picture that comes up when anyone says its name. Look at it for a moment longer. Those colors are not what your eye would see. They were pushed on purpose to make faint differences visible. Stand there yourself, and Europa would look closer to a dirty white ball with pale brown scratches. The natural color version is not what your eye would see either. It is built from violet, green, and infrared light. Nobody has ever seen this moon the way you are seeing it now. So how do we know there is an ocean under it? Nothing built by us has ever landed on that ice. Set foot there, and you would be the first ever to do it. And the ocean beneath you would still have to be inferred, never seen. So everything anyone knows about that ocean was read off the outside of it, the surface and the space around it. The surface came first, and it did not look like anything anyone expected. Countless dark bands, some running for more than 1,000 kilometers, crossing each other like a cracked shell that was never quite put back together. Trace a single one of those bands from end to end, and the obvious question arrives. What breaks a shell like this? Not once, not in one place, but over and over, across an entire moon. A spacecraft on its way past Jupiter sent back close pictures of those dark bands, sharper than anything before them. That was 1979. Someone noticed that the edges matched, put them back together, and they fit, like a torn page. A crust does not usually tear like that unless something underneath is moving. That was the first hint. Not evidence of water, but a sign that the shell was not resting on solid ground. And there the question stayed for 16 years. A suspicion, drawn from cracks, and still no way to test it. Then a spacecraft arrived that could stay, instead of flying past. It carried cameras, dust detectors, and a spectrometer, which reads the light coming off a surface to work out what it is made of. But it carried nothing that could see through the shell. Nothing on board could look under the ice. Think about the problem the way they had to. You cannot drill. You cannot land. You cannot see through. You are allowed to fly past, for a few hours, every few months, find the ocean. The answer did not come from the ice at all. It came from somewhere else, from the planet the moon goes around. Jupiter has a magnetic field, and it is vast. Europa does not orbit outside it. It orbits deep inside it, an entire world, ice and ocean and all, sitting inside the weather of another planet's magnetism. You are standing inside one right now, and you have never once felt it. And that field is tilted. Jupiter's magnetic axis leans away from the axis it spins on by about 9.6 degrees. So the field does not sit still around the moon. It sweeps. Twice every Jupiter day, the magnetic equator washes over Europa, and from the moon's point of view, the whole field rises, falls, and reverses, about every 11 hours. A changing magnetic field does something specific. Push one through anything that conducts electricity, and the material answers you back. Currents start to flow inside it. And those currents make a magnetic field of their own. A second field, born inside the object, pushing back against the one that created it. It is the same principle that heats a pan on an induction stove, except here the pan is a moon and the coil is a planet. So the plan was almost absurdly simple. Fly close to Europa, measure the magnetic field around it, and see whether the moon is answering Jupiter back. Then they flew it. In December 1996, Galileo passed 688 kilometers above the ice. The magnetometer found a field, not Jupiter's, Europa's own. If you want more of these, subscribing is what keeps them coming. But a field on its own proves nothing. Ganymede, the moon next door, makes a permanent magnetic field in its own core. If Europa's field worked the same way, everything you have heard so far would mean nothing. The two look identical on a single pass. A permanent field and an induced field both show up as a dipole. So how do you tell them apart? You have to catch the moon at the right moment. Because an induced field has no memory. It is not a property of the moon. It is a reply. Change what Jupiter is doing, and the reply has to change with it, which gave them something rare in planetary science. Not an observation to wait for, but an experiment to run. Wait until Jupiter's field points the other way, then cross it close enough that Europa fills the window beside you, and watch the needle. If it swings the other way too, something in there is answering. Then you still have to prove the answer is water. Lining that up took another 3 years, and 3 more flybys along the way. Jupiter's magnetic equator had to be on the far side, the spacecraft had to survive the radiation, and the trajectory had to be exact. And then the moment came. On the 3rd of January, 2000, Galileo passed 373 kilometers above the surface, with Europa far south of Jupiter's magnetic equator. The field it measured had turned completely around. Not weaker, not shifted. Reversed, in step with Jupiter, exactly the way a reply behaves, and a memory does not. Whatever is down there had answered in the same 11-hour rhythm it always keeps. Think about what that requires. Currents running right around the moon, close to the surface, never breaking. Something in there conducts electricity, and it wraps the entire body. Which is where the real work started. Because plenty of things conduct electricity, and most of them are not oceans. The first candidate was the thin shell of charged gas above the surface. Europa has one, stripped off the ice by radiation. It conducts electricity, so why not that? It was measured, and it failed. The gas layer conducts about 1,000 times too weakly to explain the signal. It is there, and it is nowhere near enough. The second candidate was harder. Jupiter's magnetosphere is full of fast-moving plasma, and when it slams into a moon, it generates currents that wrap around it. Those currents make magnetic fields too. This one is real, and it is big. Inside the densest plasma, it can reach 200 nanoteslas, the same scale as the signal they were trying to explain. It could not simply be dismissed. So they modeled it. Full three-dimensional simulations of the plasma, subtracted from the data. Take away everything the plasma could possibly account for, and the induced signature is still sitting there. Third candidate. Europa is thought to have a metallic core, and metal conducts better than almost anything. Why not that? Distance. A dipole field falls off with the cube of the distance, and the core sits deep. Put the conducting layer down there, and the signal reaching the spacecraft would be about 1/8 of what was measured. The measurement was strict about it. Whatever carries that current has to sit close to the surface, no deeper than about 175 kilometers down. Fall straight down from where you were standing, and you would not have to go even that far. Which leaves the outer layer itself. And the outer layer is water, frozen at the top, and the whole question is what it is doing further down. But here the physics turns on us. Pure water ice barely conducts at all. Neither does pure liquid water. At these frequencies, both are effectively transparent to magnetism. The field passes straight through. So water alone cannot answer Jupiter either, unless there is something dissolved in it. Salt. The signal does not just say there is liquid down there. It says the liquid is salty, because nothing else would have replied. That is the part I keep coming back to. Nobody has ever sampled that ocean. Salts were measured on the surface, yes, but the saltiness of the water below is not a chemical result. It is what the magnetic field had to be told in order to answer the way it did. The project scientist on Galileo put it carefully at the time, Torrance Johnson. The case for liquid water on Europa is still not clinched, and this magnetometer data is the only indication we have that there is an ocean there now, rather than in the geological past. Now, how much water? This is where the confident numbers start, and where they get shakier than almost anyone says out loud. The magnetic data gives limits, not values. It says the conducting layer must be at least 3.5 kilometers thick if it is as salty as our own seawater. A floor, not a depth. And it cannot tell those numbers apart. A thin, very salty ocean and a thick, weakly salty one answer Jupiter almost identically. The magnetic field knows something is down there. It does not know how much. So the thickness of that shell became its own argument, and it ran for decades. Stand over a shell a few kilometers thick, and a drill would already be through. Stand over 1/10 of kilometers thick, and you would barely have started. One camp read the surface. Blocks of ice that look like they floated and turned, ridges that bend as if the crust were thin enough to flex. A few kilometers, they argued. Maybe less. The other camp read the craters. Big impacts on Europa collapse into rings instead of holes, and that only works if there is a thick, warm, slow-moving layer of ice underneath to flow into the gap. Both sides were reading the same moon and getting different answers, because they were measuring different things. One was measuring the brittle lid. The other was measuring the whole shell. Then came a piece of luck. In 2022, a spacecraft that had not been sent to study Europa at all flew past it. Juno, on its way around Jupiter, skimmed 360 kilometers above the surface and pointed a microwave instrument at the ice. It measured the temperature gradient through the ice, and it came back with a number. 29 kilometers, give or take 10, for the cold, rigid layer in the region it looked at. Not thin. And impact simulations published in the same period pointed the same way, at least 20 kilometers, or those craters would have collapsed differently. 29 kilometers of solid ice, give or take 10, and that is only the rigid layer we can measure. If you could drive straight down, you would still be inside the ice 20 minutes later, except that no mission has ever been built to travel that road, which quietly damages the most repeated number in this entire story. You have heard it, twice all the water on Earth. That figure is real, and it comes from real gravity measurements. But it carries an assumption inside it, and the assumption is doing most of the work. Gravity tells you how much low-density material sits in the outer layer. It cannot tell you which part of it is frozen. Ice and liquid water differ by about 8% in density. To a gravity measurement, they are the same thing. So the famous number rests on one assumption, that only a thin skin of all that water is frozen. Assume a thick shell instead, the kind Juno measured, and the ocean underneath has far less room to fill. Run the honest range, and Europa holds somewhere between about 90% of Earth's ocean water and 3 times it. Up to twice is a defensible way to say it. A flat 2 is not a measurement. None of that makes the ocean less real. It makes it less mapped. We know something salty is down there answering Jupiter. We do not know how deep it goes. So what keeps it liquid? Not the sun. Stand on that ice and the sun is still the brightest thing in the sky, but small and far too weak to melt anything. Run the 100-kilometer figure people usually use, strip out any internal heat, and that ocean freezes solid in around 64 million years. What keeps it warm is not the sun. It is the neighbors. Io on one side, Ganymede on the other, tugging at the same points in every orbit, and never letting Europa settle into a circle. That refusal is the whole mechanism. The distance to Jupiter keeps changing. The tide inside the moon rises and falls with it, and the friction of that flexing is the heat. take Io and Ganymede out of the sky, and Europa's orbit rounds off. The flexing stops, and the ocean you have been hearing about closes over. The water is there because of where the moon sits in a crowd. Even that is not settled. Is the resonance a steady balance that is held for billions of years? Or does it cycle, with the ice thickening and thinning as the heating rises and falls? Both models are still on the table. And the surface backs the idea up in a way that is hard to argue with. Europa has almost no craters. Count what few there are, and most estimates put its face at tens to hundreds of millions of years. Crater dating is loose work, and the honest range runs much wider. Callisto, further out, wears a surface 4 billion years old. Something is erasing it, and the most elegant evidence on the surface is a set of curved cracks. Their geometry only works if the stress field turns a full circle every orbit, and that can only happen if the shell is not locked to the rock underneath. A pattern on the surface gives away the ocean below. So the case is built from the outside in. Magnetism, tides, cracks. Every line of evidence circles the ocean without ever touching it. For about a decade, it looked like that was about to change. Because if the ocean were venting into space, and if that spray really came from the deep water rather than some shallow pocket, you would not need to drill at all. Fly through it and you would be carrying another world's sea past your instruments. In 2014, a team reported exactly that. Hubble had picked up an excess of ultraviolet emission over Europa's south pole, the signature of water molecules being torn apart. They put the confidence at 99.9%. 2 years later, another team reported dark shapes at the moon's edge in 3 of 10 attempts as it crossed in front of Jupiter's bright face. Then someone went back to Galileo's old magnetic readings and found a kink that looked like the spacecraft had flown straight through a plume. 3 independent lines, pointing the same way. And then the thing you were being shown started to disappear. Follow-up observations came back empty. If the plumes existed, they had to be rare and intermittent. Then the James Webb Space Telescope looked and found nothing venting at all. This year, the original Discovery team went back through the Hubble archive. 14 years of usable observations spread across 2 decades, including their own. They found that the location of Europa's disk on the detector, off by 1 or 2 pixels, was enough to manufacture the signal. Add Earth's own hydrogen glow, which had not been fully subtracted, and the plumes vanished from the data entirely. Stand on that southern ice in 2014, and the story said a jet of water was rising 200 kilometers over your head. Stand there now, and that jet is gone from the data. The older evidence went the same way, from a direction nobody expected. Calibrated readings from one of Galileo's instruments, the one that counted charged particles, had sat unpublished for nearly 30 years. When they were opened, the density near closest approach was nowhere near what the plume model needed. Normal ionosphere, not a plume. The one route that might have carried a sample up from below without drilling through kilometers of ice has had its evidence withdrawn, piece by piece. It is worth being clear about what happened there. Nobody faked anything. A team published what the data seemed to show, other people checked, and the same team went back and took it apart. If you have ever been told that scientists never admit mistakes, this is the counterexample, in public, with names on it. Which leaves an obvious question. If the spray is gone, is anything from that ocean reaching the surface at all? The Webb telescope, which found no plumes, found something else. Carbon dioxide, frozen on the surface, and not spread evenly the way delivered material would be. It is concentrated in one broken region called Terra Regio. Meteorites would dust the whole moon. Radiation would work everywhere. But the carbon dioxide is concentrated where the crust is torn up, and that pattern points downward. It does not survive long on that surface, so what we are seeing must be recent. So there is carbon in this system, and the pattern says it came from below. And this is exactly the point where most of the internet stops being careful. The team measured the carbon isotopes, the ratio that can sometimes separate biology from ordinary chemistry. The measurement came back unable to tell the difference. Not suggestive. Unable. What is actually established is narrower and worth saying plainly. Liquid water, inferred strongly. Salts on the surface, measured. Chemical energy and oxidants, measured. Carbon, measured. Life, nothing. No evidence of any kind. But one condition everyone assumes is not established at all, whether that ocean touches rock. If the water layer is thick and cold enough, high-pressure ice forms at the bottom and seals it off from the seafloor entirely. Whether that contact exists decides what kind of ocean it is. On Earth, the chemistry that may have started life happens where water meets hot rock in the dark under crushing pressure. Take that contact away, and Europa's ocean is still an ocean, but it is sealed top and bottom by ice, with no hot rock anywhere in it. The surface is no shelter either. Jupiter's radiation belts pour enough energy onto that ice to tear water molecules apart several times over within a century. Stand on it, and the shell under your feet is the only shield there is. Nothing organic lasts on top of it. Which is the reason a spacecraft is on its way there right now, and the reason it will not stay. The answer is already on its way. Europa Clipper launched in October 2024, and it reaches Jupiter in 2030. It will not orbit Europa, because anything parked in that radiation would not last long. Instead, it loops around Jupiter and dives past the Moon 49 times, dropping in and pulling back out before the radiation adds up. Each pass buys a few hours of measurement, paid for with a long retreat. And it is built to break the exact deadlock this whole story runs on. Galileo could only measure the Moon's reply at one rhythm. Clipper measures it at several, over dozens of passes, and that is what separates thickness from saltiness from depth. It also carries radar that can look down into the ice and listen for the echo off the bottom. If that echo comes back, it is the first time anyone has measured where the ice ends and the water begins. What it is not carrying is a microscope. Clipper is not looking for life, and it cannot find it. It is there to measure whether the conditions are right. The people who built it are unusually blunt about that distinction. One last detail says something about how carefully this has been handled. When Galileo's mission ended in 2003, they did not leave it in orbit. They flew it into Jupiter on purpose. The reason was Europa. A dead spacecraft drifting in that system might eventually hit the Moon and carry Earth bacteria into water we had not examined yet. So they destroyed a spacecraft that was still sending data to protect an ocean nobody has ever seen. Go back to where this started. The picture you recognize is color that was pushed to show us something our eyes cannot pick up. The ocean underneath it was found the same way. By measuring a reply we could not see. Almost everything we know about that moon is like this. Not a photograph, but a careful argument, built out of what a magnetic field did and what craters could not do. Tonight, while you are watching this, that ocean is still down there, still unseen, still answering Jupiter every 11 hours. Since Galileo first heard it answer, it has replied more than 20,000 times. Nobody has seen a drop of it. And then the argument ends. In 2030, a spacecraft that has been traveling for more than 5 years starts sending back the measurements that settle it. Some of what you have heard tonight will not survive them. If you want the other end of this story, look for the Saturn mission that was deliberately burned up to protect the ocean moons it had found. That one is already on the channel. What is known, we showed you. What is not, we marked. Somewhere out there, the next story is already unfolding.